Hey guys, so in section 1.3 what we're going to be introducing are roots and irrational numbers. So a square root, first of all, is a number that is multiplied by itself to form a product that's a square root of that product. So basically what that means is think of 2 times 2 equals 4. That means that 2 is going to be your square root of 4 because multiply 2 by itself you get 4. The radical symbol, that little squiggly we got there, so radical symbol is used to represent our square roots. I put a few examples down right there, although they're kind of messy. Thought we were going to do this in class, but we're not. Square root of 3, that's one example. Square root of, I think I tried to put like 9 there. I don't know what that is. Square root of 4. Or you could put a square root of an expression, 2x plus 4. That's an algebraic expression. Could all go inside a square root. Still works. This blank right here we're talking about for all non-negative numbers. So I first put positive, but again, this also works for 0. So non-negative numbers, the operations of squaring and finding a square root are inverses. And that means they're kind of one and the same. They're just a little bit backwards. That means if I have something like a squared is equal to b, if I flip that, and again, a little mistake there. If I flip that, I can say the square root of b is equal to a. So just kind of looking at it forwards and backwards. Take one number and square it. I get another number. Or I can look at that number, take a square root, and get the first one. So a squared equals b. The opposite of that is saying the square root of b is a. So anytime you have positive real numbers, they should have 2 square roots. And what we call the principal of the square root of a number is the positive square root, and we just use that regular radical sign for it. So principal square root, we're just thinking of the positive answer. Remember, positive numbers should have 2 square roots. So a negative square root, we represent that by a negative and then our radical sign, so negative radical. And this symbol, we call that plus or minus radical. We use that to represent both of those square roots. So plus or minus a square root. Example would be our principal square root of 36. So just square root of 36 would be 6. If I want a negative square root of 49, that would be like a negative 7. Or I could look for both. Again, plus or minus the square root of 25. Looking for both. That could be either 5 or negative 5. And remember, your negative square roots still work because, again, if I did square root of 25, negative times negative 5, negatives cancel out, still makes a positive 25. So a perfect square, that's a number whose positive square root is a whole number. So, for example, we have our table right here with some of your more common perfect squares and square roots. If I take 1, perfect square of 1 is 1. Perfect square of 4, the square root of 4 is 2. So again, if I take 2 and square it, I get 4. Remember, those are inverses. If I take 3, again, the perfect square is 9, and vice versa. If I take 9, square root of 9 is 3. So 4 squared, so perfect square is 16. Square root of 16 is 4. Same thing, square root of 25 is 5. Square root of 36 is 6, and so on for these other ones. These are your more common square roots that we're going to see. So again, we can see the perfect square and square root kind of just go forwards and backwards. Take 2 times 2, I get 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And so on down that list. Moving on, before I get to our practice problems I guess, a number that is raised to a third power, we don't call it a square root. We call that a cube root if that's that product. So that symbol looks like the same thing, except there's a little 3 inside of that radical sign. We use that to indicate a cube root. So if I have the cube root, for example, of 8, that would be 2, because 2 times 2 times 2 is 8. Basically, you want to think that number right there is just telling you how many times you need to multiply a number together to get what's inside of that radical. So if I'm trying to multiply a number 3 times to get 8, I need to multiply 2 by itself 3 times to get 8. So the same thing works for 27. 3 times 3 times 3 is 27, so the cube root of 27 is 3. It also works for negatives. If I take the cube root of a negative 64, for example, that would be negative 4, because negative 4 times negative 4 times negative 4, that's going to give you negative 64. So you could go even farther than that. If I change that symbol to, instead of a 3, now it's a 4, I could just call that a fourth root. That's just going to be, for example, fourth root of 16 is 2. 2 times 2 times 2 times 2 is 16. Fourth root of 81 is 3, because again, you multiply 3 by itself 4 times, you get 81. And actually, notice there's a little mistake on that last one too. I tried to include a negative, but negatives actually only work if there are an odd number. So this one is actually not quite correct. It should be a positive in there. So fourth root of 256 would be a positive 4. So if those are both positive, it would work. Try to get a little bit fancy, but again, that only works if there's an odd number. So trying to find those square roots, again, just give yourself some time to see if you can get as many of these as possible. I'm going to continue with the video in a second, so go ahead and pause. So trying to find all those square roots, again, if I was looking for the square root of 49, that should be 7. 7 times 7 is 49. This is looking for a negative square root, so the negative square root of 36 is 6. The cube root of 27 is 3, because again, 3 times 3 times 3 is 27. The cube root of negative 125 is negative 5. Negative 5 times negative 5 times negative 5 is going to give you negative 125. Remember, those negatives work if it's an odd number. So 3, that's an odd number. That negative does work. So the fourth root of 81, that should be 3, because 3 multiplied by itself 4 times gives you 81. Negative root of 81, that should be negative 9. The cube root of 8, that should be 2, because again, multiply 2 by itself 3 times, it gives you 8. And the cube root of 216 is 6, because 6 times 6 times 6 gives you 216. So trying some more on the back, cover that up for a bit. When we want to take a root of a fraction, what do we have to do is take the root of the numerator and the denominator separately. Again, a good thing I like about fractions is that fraction bar acts as a grouping symbol. And then we want to reduce the fraction if we can. So after you do this square root, then we're going to reduce it if possible. So give yourself a second to pause and try these. About to cover those now. So let's see. If I take the square root of 4/9, again, just look at that as two separate parts. Square root of 4, square root of 9, I get 2/3. Same idea if it's a cube root. So cube root of 1/8, I take the cube root of 1, that's 1. Cube root of 8, that's 2. So I get 1/2. Same idea here. Cube root of 8 is 2. Cube root of 125 is 5. I get 2/5 if I take a cube root. Looking at a few more. Fourth root of 1/16. Fourth root of 1 is 1. Fourth root of 16 is 2. And again, negative square roots. So negative square root of 49 is 7. Negative square root of 81 is 9. Last one is another cube root. Cube root of 1 is 1. And the cube root of 27 is 3. So whenever you get a fraction, just make sure you do top and bottom separate, and it should work otherwise the same way as anything else. So now we're going to classify some numbers based on what common characteristics they have. So if I look at this entire list here, so real numbers can be classified according to, they could either be natural numbers. Those are counting numbers, 1, 2, 3, 4, 5, 6, so on and so forth. Whole numbers, that's the natural numbers, but also includes 0. So I do the same natural numbers, but I throw 0 in front. And integers are the whole numbers and their opposites. So I take all those counting numbers, 0 for the whole numbers, but then I can also use negatives. Negative 1, negative 2, negative 3. Notice we're not using any fractions or decimals here, just basically whole numbers and their negatives. So rational numbers, numbers that I could express in the form a over b, where a and b are both integers and b is not 0. Basically what that just means is it can be a fraction as long as both parts of the fraction are your integer numbers. And again, we can't put a 0 on the bottom of the fraction, can't divide by 0, so make sure we don't have that. When you use a decimal, rational number can either be a terminating decimal or a repeating decimal. So terminating decimal means basically it terminates, it finishes. So there's a set number of places after the decimal point. Examples that I came up with, 1/4, there's 2 decimal places, that's just 0.25. 1/10, just 1 decimal place, 0.1. And 1/8, it's comes out to 0.125, and it does terminate. Notice those are all written as fractions, and they use integers, so those are all rational. A repeating decimal has a block of 1 or more digits after the decimal point that repeat infinitely, forever. So that means all digits also can't be 0. So I can't just say like 1/10 is repeating just because there's a bunch of zeros afterwards. I need an actual block. So 1/3, for example, is 0.333333, keeps going. 1/11th, I came up with another example, that's just 0.09090909, that keeps repeating. Another way you can express that is with a little bar over the top. So if the 3 keeps repeating, just put 0.3 with a bar. And if we have that 0.09 that keeps repeating, that's just 0.09 with that bar. Irrational, so we have either rational numbers or irrational numbers. That just means that all the numbers that aren't rational, that just fits into the category that they're irrational. So these numbers can't be expressed as a quotient of 2 integers. Again, they can't be written as a fraction. It's basically how you want to think about that. They're never terminating and they're never repeating, so they're different from what we saw up here. So some examples, square root of 2, 1.4121 comes up with a bunch of different numbers after that. It just doesn't have a pattern, doesn't terminate. So that's irrational. Pi is another common one that's irrational. So 3.14159, I can look over at the board and cheat, but I don't know by heart all the ones after that. So doesn't repeat, doesn't terminate, so pi is irrational. There are other examples, but again, just want to think numbers that are not rational. If a whole number is not a perfect square, then that means its square root is irrational. So for example, square root of 4, that's a perfect square. So square root is 2, that's going to be rational. But on the other hand, if I try and do the square root of 3, it doesn't come out evenly, it's a big, scary, ugly decimal. That's not going to be a repeating decimal, not going to be a terminating decimal. That is going to be irrational. So we're going to continue this in class later. Just make sure you have these down, and we'll see if we can wrap that up.